G'day Internet, welcome back to another video. This here is my recently arrived Dragon 32 and cosmetically it's in quite good condition. However, it is missing one vital component, the power supply, which makes this currently a very interesting looking paperweight. So I did some research and I asked around and essentially I came up with 3 different options for replacing the power supply. You can either, using modern components, rebuild the original power supply, which fed out a couple of different AC voltages, which then feeds into the DB9 connector on the back of the machine. And yes, that is a very weird connector to use for power. Then all the rectification and DC conversion stuff happens on a power board inside, and then +5, -5, and +12 gets fed to the actual computer. Now, they may sound like fairly common voltages, and they are. Because one of the other options that I saw is someone who basically gutted the entire internal power board and mounted a modern Meanwell power supply inside. And look, that wasn't bad, but it requires a lot of modification to the original machine. Becomes a bit messy with the power connector and the switch on the back. And like having the original power supply, it still keeps all the heat inside the machine. So I thought I'd take the idea of that one and take a different route to it. And that is to build a Meanwell power supply externally in a box, feed the DC voltages through the DB9 connector on the back, bypass using a few small reversible modifications on the internal power board, and feed that directly to the main board of the computer. And that's what we're going to do today. Right, so ignore the kind of noise in the background. That's my desoldering gun and soldering iron heating up. So this is the power board out of the Dragon. What we're essentially going to do is the power comes through this DB9 connector here, which yes, I realize is kind of weird, but it actually works in our favor. Goes into the switch, out of the switch, and then through all this rectification and all the rest of it, and pops out here as +5, +12, and -12 on various pins. What we want to do is this, is from our Meanwell here, which gives us our +, -12, and +5, we want to feed that directly into the DB9, into the switch, out of the switch, bypass all of this, and basically plumb it directly into the back of this cable here. So to do that, we kind of need to get all of this out of the way, but I want to do it in a way that's reversible. So there's a whole bunch of these diodes which are going to have one leg desoldered, lifted out and insulated, and that removes, that's the switch end basically taken care of. Then at this end, it's going to require desoldering basically the 3 rectifiers. So there's one there, and one there, and they'll carefully be put away for safekeeping. But at the end of the day, if I was to use all this rectification, I'd probably replace them and the capacitors and everything else anyway. So let's start by desoldering these legs on here. And if we map this out, and I have a bit of a cheat sheet here, whatever I did with it, that's the contact. Here's the switch. I've got my little cheat sheet here. Coming out of the switch, and then we need to remove this spot, this one, which then goes down to this one, and we need one more, so it will be this one and this one. So I'm going to get started on that. Right, well, in the process of doing that, a couple of the old solder joints cracked, and so the big diodes ended up falling out anyway. So I've actually just removed the 4 big diodes and isolated the 2 small ones. So that is now the switch isolated. Now we need to isolate the header, and like I said, what we need to do is we need to remove 1, 2, and 3 rectifiers. So I'm going to start with this one here because for some reason it's not screwed down. Right, this second rectifier just became a lot more interesting because the screw is completely soldered in. So let's see what I can do with the desoldering gun. I'll get rid of the 2 pins first. All right, you know what? That screw can stay there. But we should now have an isolated ribbon cable here. So let me just get rid of all this stuff out of the way. It's also like 30 degrees today and I'm in the shed. So what we want to do now is we want to join basically where we've desoldered, but we'll go right back to the pins on the actual switch. Here, here, and what was the other one we did? Here to here. But we need to know what pins are what, and I have a bit of a layout. I've done some planning. Right, so most of this we don't actually care about. We've got ground, so we're not actually worried about ground. We only want the 3 others. And we've got plus 12, plus 5, and minus 5. So we want to go from here up to here. Now at this point it doesn't really matter which one we do, as long as we then wire up the plug to match. So we don't need ground. We want 12 volt, plus 5 and minus 5. Right, so that's that end. Now we want to route them up here. So let's start by getting the solder on here. I did say we were going to go straight to the switch, didn't we? Oh, we'll use these ones. Doesn't matter. Okay, so that's that done. I can turn that off. And by rights, with the switch off, we should not be able to go from here to here, or here to here, or here to here. but we should be able to now go from here to here, yep, here to here, yep, and here to, wait a minute, where did that go? Oh, it's that one, right. That's our +5 there, and this is all ground, and ground is always connected. Cool, right. That's the modifications to the power board done. Okay, the next bit I want to do is wire up the DB9 connector that will eventually go into here like that. So, now, remembering our pin out, so that one is that pin there, so we want to start with 12 volt to that, although the wire I've got isn't really color coded, so it's not really that big a deal. Right, so it turns out the wire was actually reasonably color-coded. Just remember that white is our negative, and we'll be fine from there. So that's our -5. Instead of blue, it's now white. So the next thing I want to do is I want to bring in our Meanwell power supply, and this is what's going to give us our plus, minus, etc., etc. So we've got... let's wire this up. Now this is just an IEC cable that I've hacked the plug off. So let me grab an appropriate screwdriver. Going by the Australian standard, first we've got active, or on this case it's marked live, but let's put U in. Next is our neutral, which is in Australia blue. And finally, green and yellow is earth. Or would that be green and gold because it's Australian? Right, what I want to do now is I simply want to test the voltages out of this. So I'm going to carefully switch off the power point, plug it in, and we should get, where's my multimeter? Now, this is 240 volts sitting right here, so if you're doing this yourself, God's sake, be careful. Right, we have an LED, that's good. We should get 5 volts, yes. We should get 12 volts, yes, and we should get -5 volts. Awesome, right, we have the correct voltages out of this. I will now carefully switch it off and unplug it. And because we're only at the testing stage at this point, I'm going to just wire up our the other end of our DB9 cable into here, and then double check the voltages again. Then we'll plug it into the power board and so on and so forth. Right, there's our DC line in. And I bring up our DB9 connector. Right, plug the Meanwell in, turn it on, light's green. If I come down here to ground, I should get -5, 5, and 12, and I do. Awesome, right. This bit is now done, but the next thing I want to do is plug this kind of hacked together version into the power board and make sure that we're all okay there as well. All right, we're in here. Plug it in, turn it on, nothing went bang. Is the power switch on or off? It was actually off. Right, so we should have nothing, 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 nothing. Switch it on and we should get, why about -5 there and -12? that's not right. It's because I had the multimeter around the wrong way. Right. -5, 5, and 12, or 11.7, close enough. Right. This is now actually all done. What we want to do now is actually build the power supply into something useful. Right, now that we have a power supply that electrically works, we need to actually turn it into, well, a power supply, a usable one, which means things like fuses and switches and a box and things like that. So let's get started. So this needs to start by mounting, well, we're going to start by mounting the power supply actually in the box. This is just a jiffy box. Put you to one side. And this needs to sit smack bang in the middle. But what I do have is I've cut out a little template based on the data sheet and printed it to scale. And that means that we should be able to place this right there and be able to mark out our holes. Right, marking black on black probably isn't the world's greatest idea, but I can see them. So let's drill some 4mm holes. Right, there are our holes, and if I've done this correctly, this should line up. Well, the two external ones do, and what we want is some M3 screws and nuts. And this should all go together. Now, the Meanwell power supply uses two M3 screws just there. These are my longer ones. I think I'm going to want my shorter ones. And hopefully they poke through enough. Yes, they should. Right. Now the fun bit of actually finding the holes. There's one. Just loose. Second one. Right, that's that done, and now we're going to, there's one back here and one here, and we're going to nut and bolt those. Right, after much swearing, that is now mounted. The next thing we want to concern ourselves with is wire in, fuse and switch. So here's the lid, this goes on here. The problem is we don't actually have much height and we don't actually have much depth, because by the time you take into account a fuse needs to go kind of here, and there's two of them, that doesn't leave us huge amounts of space. Now, I want to try and mount these as high as possible as I can, one on each side, and then bring the cables in lower and more to the center. And I've marked these out here. So I'm going to start with some pilot holes. So they will mount in there. Now, the grommets that we're going to use have basically a 10mm diameter once they get in there. And again, my step piece should have a 10mm line on it, which is basically the first one. there's our holes drilled for this end, and I should be able to remove the tape. Nice. They even look remotely straight. Get rid of all this plastic mess. Okay, so what we want to do is, let's start with mounting the fuses. Fuses. Next we want to feed our cables through. So I have them here somewhere. To make this at least somewhat neat, we know DC is this side and AC is this side. So let's start with AC. Start with a grommet. And the fun job of trying to squeeze a grommet through the hole. Right, we're in. I'm not going to say that was fun because it wasn't. So I've gone ahead and actually mounted the switch. There's just another hole at the other end. Now, we're going to concentrate on the mains wiring first. The neutral and the earth can go straight to the power supply, but the live needs to go from here to one of the fuses to the switch and then into the power supply. So I'm going to start on that. And in hindsight, I probably should have done that first, but it's going to be a bit difficult to see. But I'm going to start by putting in the wire from the fuse to the switch. Right, and I've also put in the wire that will go back to the power supply. Next, we want to join up this to the back of the fuse, and that's going to cause us issues when we go to actually wire this up. So I'm just going to leave that just for now. Now, looking at the DC side, we've got our 5, our 12, our minus 12, and our ground. Now, the plus 12 and negative 12, they can go straight to the power supply, so can the ground, but the 5 volt needs to go through the other fuse. And the reason for that is the Meanwell power supply actually will pump out 6 amps on the 5 volt line. I was talking to BWAC about this, and he said the good idea to drop in a 2 amp fuse, because at the end of the day, if something was to short in the computer, this thing will just keep pumping voltage at it and like burn your house down. So we're going to use the other fuse here for that. This is going to require some extension on this red wire here, and then another red wire which will eventually end up at the power supply. And last but not least, we need to run 12 volt and ground to the switch for the illumination. Right, so because I've basically been working in a box and it's been hard to show you, here's our AC fuse up the top here, our DC fuse here. You can see the red wire coming off the fuse. Here's our wire that goes from the fuse to the switch, and here's our wire that goes from the switch to the power supply. So this is where it now starts to get a little tricky, because I kind of need to be able to connect everything up, and we're dealing with some short-ish wires which I may yet have to extend, I'm not sure, because, for instance, this needs to go to here, this needs to go to here, but these still need to be screwed down. So, and it's a bit the same with this one as well. Now, before I do, there's just one thing I want to do, and let me be clear, this is purely out of paranoia than anything else. I've measured this all up, and I'm pretty confident, or quite confident, that neither the switch or the fuses will touch the power supply. But, just to be safe, I'm going to put a couple of layers of thick duct tape in appropriate places, just to make sure that I haven't screwed up. Right, so if anything does touch, it'll touch this and not the metal case, which is connected to the mains earth. So that's why we're doing that. Right, because a lot of that probably wasn't actually viewable to you, you can see all this is all the wiring done and the limited space I had to work in. So everything's now connected. We've got mains coming into the power supply, with the exception of the live, which goes through the fuse, then the switch, then to the power supply. We've then got our DC out, which goes straight into here for most of it, except for the 5 volt, which goes into a fuse and then into here. And then we've got the illumination on the switch, which is 12 volt, which also picks up off the plus 12 and ground here on the Meanwell power supply. The next thing is to actually make sure all this fits. There we go, it all came together quite nicely. I even made a little badge for the front and even remembered to label the fuses on the back. But now comes the real test. Does it actually still work with the computer now that it's all buttoned up? Right, so before we get to the moment of truth, just to let you know, I did put the diodes back into the power board, just one leg of them, so I don't lose them. The 2 small rectifiers got bolted back in, but still disconnected, and the big rectifier is actually just double-sided sticky tape in there, mainly so I don't lose it. And so this can be quite easily put back to standard should the need ever arise. But, right, if we go on, we have light, and there we go. It works. It's not the greatest image quality in the world, but it does work, and that's the main thing. So I now have a working power supply for my Dragon 32, and that is fantastic. It's all working. However, as it currently stands, the only thing I can actually do is poke around in BASIC. Not that there's anything wrong with that. I would just prefer a way of being able to load software on this machine. But that will be the subject of a future episode. For now though, if you liked the video, click like, subscribe, all that kind of stuff. If you'd like to help support the channel, you can find me on Patreon, just like these wonderful people here. And until then, I'll catch you in the next one.